What's up, guys? Chris with CNC for Newbies. Just wanted to go live and give you guys an update on some pretty cool happenings here. I showed you guys the PLC setups that I made. One is just a opto-isolated input-output board, and the other one is an opto-isolated input-output relay board. So they actually stack together and they can work together. A lot of people, couldn't figure out what the purpose of this was, and it was to actually make the ability to have multiple voltages running at the same time and allow UCCNC to have the inputs and outputs for safety features. So I can actually program the PLC to recognize the tool release and the tool clamp. So it'll designate whether or not it has a tool in the tool holder, which is really good. But a lot of people don't realize how much work went into these. And I'm going to show you guys kind of some background stuff on programming and compiling, because a lot of you guys know how to compile Gerbil. Okay, Gerbil is nothing more than a program that's loaded on an Arduino. Okay, so a lot of people will use the IDE to actually program the Arduino. There are other ways of programming an Arduino also. So one of the first things we have to understand when we're playing with these Arduinos, this is nothing more than an Arduino Nano, just like in the Gerbil converters, the Gerbil control boxes, and Nano is just a smaller form factor of the Uno. Okay, so both of them can be programmed the same way. So if you're running like an X controller, that's an Arduino. Millwright is using an Arduino Mega. Not necessarily the same, but it has some of the same functions. Okay. But the Nano and the Uno are very, very similar. So one of the things we need to know when we're going to make this stuff are what are called pinouts. Okay. So this is the Arduino Nano pinout. Okay. That's what we use to actually tell the Arduino what pins to make high and what pins to make low. So when you guys are using your touch probes, you're telling it, hey, this pin is high, hey, this pin is low. And when you do that, it basically looks for a voltage or a lack of voltage on those pins. Okay. That's a lot of jargon to basically tell something, hey, look for this. These do the same exact thing. It uses an isolated setup. We use opto isolators on everything, which are these pieces right here. And we basically tell it, hey, if there's voltage on this pin, make it high and recognize that when that's high, that's going to say, okay, give it the safety function. Okay. Now, how to program those things. You guys have looked at the Arduino IDE or the hex files and stuff like that. And the Arduino IDE actually creates the libraries to create hex files. And the hex file is what gets loaded on the computer chip here. and tells the Arduino what to do. I don't program in the IDE as much when dealing with PLC type controllers. PLC type controllers usually use what's called ladder logic. Okay, and I'm going to show you guys a version of ladder logic. So this is ladder logic, and ladder logically basically says, hey, here's a switch, and then if this switch is on, look for this part. So on here we have an on switch, and that on switch says, okay, when that closes, go to the next rung or the next process in the ladder. So we turn the on switch on, and it goes here to this branch. So it goes to a branch looking for either a manual switch or an auto switch. So in this case, this PLC is programmed to run a fluid control process for water for the spindle. Okay, so if it runs it for the spindle, it'll tell me, hey, add water or don't add water. You're good, stuff like that. But I can also program it to turn on a pump solenoid to pump water into the spindle bucket so that I have the proper height for spindle. I can also tell it, hey, I want it to recognize that there's a low level sensor and a high level sensor, and they both need to be closed to turn the pump off. Okay. So here's how we do that. Let's take that down a little bit. Okay. Let's take it down one more. Okay. So now we have all of that on one screen. So now if I have it on manual, it goes right to turning the pump on and fills the spindle bucket with water. If I have it on auto, it looks for this M1 function here. This M1 function says, hey, if the low level sensor is triggered and closed, we're fine. But if the high level sensor is not triggered and closed, we need to operate M1. And basically that says operate the pump. Okay, so right here's our M1. Here's our separation of if we have one switch active and one switch not active, it's going to operate the pump. Okay, and that's all designated by this call here, which is right here in the ladder. So this is a different rung, and it says, okay, this is the criteria. Something's not met, go to this rung and resolve. Okay, so now with this, I go to the next rung and I can actually put in, oh, damn. Okay, I can put in, I can put in a low level sensor closed. If the low level sensor is closed, then you can turn on the low level indicator. If the high level sensor is closed, it goes to M2, and M2 turns on the high level or full. So basically I have a low and a high indicator. And then M1 and M2 tell it, hey, either turn on the full or turn on the pump. So if it's not reading full, it has to turn on the pump. All right. And all of that is held on the nanos here on these two boards that can operate completely independent of each other, or they can be paired together to make a real robust system, which is really cool because you can operate more functions at different voltages and not burn up your controller. And then on top of that, you can actually offload some of the Gerbil functions onto these PLCs and be able to control different aspects of different things. So maybe you want to add rotary without doing a rotary switch. You could add this in and actually have a relay take over the function and whatnot. And it'll say, hey, if the program is switched for this, then this type stuff. So that's how I program a nano with PLC logic, with ladder logic. Now, what does that look like in the IDE? It looks similar to this. Let's stop screen share. Let's go to this. So these are the actual libraries that are included. This is a standard integer hex file, a standard library hex file, a string hex file, AVR input output hex file, and an AVR interpreter hex file. Okay. All of these things are what actually tells the Arduino what to look for. So everything that I programmed in that ladder logic is all written here in the compiler. And you'll notice we're looking at integers, and we're looking at things that violate integer sections, statistic violators, unassigned integers. So these integers actually are just little bits. You've heard of 8-bit and 16-bit. It basically just takes one of those bits and says, okay, this is the bit that I'm looking for. And then if that bit is here and it's positive or true, then do this. If it's there and it says false, don't do this. And basically I just go through and I have a truth table and I look at the branches, and this is my compiler loop. So this is a lot of the stuff in the background that you guys don't see. And when I say you don't see it, let's see here. We have, so whenever I start off, the very first thing that I do is I write out my inputs and outputs. And for these, that's already dictated for me by inputs on this side because there's no relays, outputs on this side because there are relays. And then here I have my PWM outputs. So all of these are digital and analog inputs. Digital is either off or on. Analog, it can be a frequency based on voltage input. So like if you want to dim an LED to a certain color or a certain brightness, that would be an analog input with a potentiometer. That would have to be a PWM output so that the frequency was pulsed at a rate that made it dim down. So those are my input output assignments based on the inputs and outputs of the Arduino Nano. Then I have to write down my variables, the if this then this statements and what they do. I have to get my initial library started. And then finally, I have to start writing my ladder logic of how I want my rungs to go. And that's kind of how I start compiling everything and doing everything. And it's pretty cool to know that we as individuals have the ability to do this in this day and age, because a lot of this stuff was reserved for people who didn't have this ability. Okay. The are reserved for people who only had the ability, not that didn't. So you really had to know programming language. Well, the fact of the matter is there's very few people that are going to know programming language and be interested in CNC and the CNC programming at that. Okay. But we as hobbyists have the ability to build these in-house by ourselves and do whatever we want with them. So I think that's pretty cool. And that's pretty much all there is to it. So you can see there are a lot of if and when statements on this. There's a lot of unassigned integer readers. This is a lot more complex than your typical Gerbil output. But you know, it is what it is. The storage space, you know, obviously, you know, there's a lot to be said for compiling this setup. My sketches are very small sketches. Mine's only 454 bytes, which uses 1% of what's storable on a Arduino Uno. It doesn't use any of the EEPROM global variables, so it has all of its dynamic memory still there. So I'm pretty proud of this project. I know it sounds really weird and what's it going to do for us, but when you think of the fact that you can stack this and this together and you can control your temperature of your spindle water, you can throw an alarm if it goes over a certain temperature. You can throw an alarm if your spindle body gets too hot. You can throw an alarm if the tool doesn't get picked up in the collet holder, in the tool holder for the automatic tool changer. You can say, hey, it did get picked up, so go ahead and move, which is two of our safety features that we're working with. You know, you can do so much with these different PLC setups and everything that I really think more people ought to look into this and ought to implement this and go from there. All right. So with that being said, I guess I'll let you guys get back and I'll talk to you later. Keep on carving. Let me see your projects and I'll talk to you later. Peace.